Hi, in this section, I'm going to be talking about the tidyr package. So what does the tidyr package does? It is used for tidying your data, and a tidy data is when every column is a variable and every row is an observation and every cell is a value. So that is a tidy data. So you can see all the data we have been working with in the previous sections. These are tidied data. If you want to use the tidy data, you have to first have it on your system. I'm going to use the install.packages, then tidyr. So for those of you that don't have it, this is what you are going to use to install the tidyr package on your app. Then you now load the library tidyr. So this is going to load our tidyr library. So this tidyr, with some functions, this tidyr, if you have a data which is unordered or is not clean, then you can use this tidyr package to clean that particular data, as you are going to be seeing in the next lectures. In this lecture, I'm going to be talking about reshaping with pivots longer. So we're going to be making use of the religious income dataset, which comes with the tidyr package as a case study. So let's have a view of the religious income dataset. So this is a data set for a religious and income survey. So the incomes of various religions all over the globe. So as you can see it, so this is a survey. So in this survey, you can see that we have column religion. We also have column of different income ranges. We have less than $10,000. This is yearly, and also the range of $10,000 to $20,000. We also have $20,000 to $30,000. So up to the second to last column, which is greater than $150,000. You can also see we have a column of don't know or refuse. So these are people that refuse to give their income or they don't know their yearly income. It was a survey on a particular group of maybe a community. So in that survey, then various religions were asked about their range of income. So for people that are agnostic, we have 27 people that are getting less than $10,000. If you check for the range of $10,000 to $20,000, we have 34 people. So this is just like the frequency. So for each religion, we have the number of people that are having that amount of income. Then we also have a column don't know / refuse. These are those that refuse to give or they don't know their yearly income. So now if you look at this data set now, this data set is not tidied in the sense that we are having the incomes as columns, which is not supposed to be so. We are supposed to be having this income in a single column. All these income columns, all these incomes that we are seeing here as columns should be values in a single cell called salary, or let's say income. So we're going to create a new variable called income, and all these columns are going to be converted to values under that particular variable called income. So why these values are going to be given as count? So this table that you're looking at is like a cross tab. So, but for us to be able to tidy this data or perform an analysis on this data, then we need it to have a variable called income. So we cannot be using columns of income ranges. We need to create a variable called incomes. Then these incomes can now fall as values under that particular variable. So this is where this pivot longer comes. So from the name pivot longer, this is a wide table. So we're going to convert this wide table to a long table. So we should be expecting 3 variables. Instead of in this situation when we are having 11 variables or 11 columns, we want to be expecting just only 3 columns, where these incomes are going to fall as values under that particular variable we are creating, the new variable we are creating called income, and also the other new variable also will be creating where these values are going to be sent to. So now we are going to see as I'm going to use the pivot longer to lengthen this data and reduce the number of columns. So the pivot longer, in summary, lengthens the data and reduces the number of columns in the data. So it lengthens the rows of the data and reduces the number of columns. So now the first thing we're going to do, we're going to pass our religious income. We're going to pass our religious income data to the pivot longer function. So now this pivot longer function is going to take the rows that we're interested in. So we're interested in converting these particular columns. We're not interested in this particular column called religion. We're interested in these salary columns or income columns. These are the columns we want to convert as values in a new column called income. So we're going to say columns is going to be equals to not religion. Remember our not operator, we have talked about it in the previous section. So columns is going to be equals to not religion. So we're selecting all the columns except religion. So those are the columns that we want to compress, or we want to compress it to rows. Then we're now going to say names to So what is the new variable that we are creating? We are creating a new variable in a new column called income. So income, then values 2. So if you remember, we have values under this table. You can see these values. So what is going to happen to these values after we already compressed this already to rows? So what is going to happen to these values? So these values are going to be taken on a new column. So it is that column now that we are going to call count. So when we run this, you can now see that we have 3 columns in our data. We have religion, income, and count. So this is now a tidied data. And if you check, we have 180 rows. So the number of rows has increased from 18 to 180. So when you look at these remaining columns, they are 10. So when you multiply 10 by 10, you have what? 180. So it has already compressed, or it has converted these columns, these plenty columns we have, it has converted it to values inside rows. So you can now see that income is now a new column on its own, having the income rate. So you can see that agnostics that have less than $10,000 in a year, that are earning less than $10,000 in a year, are 27. You can also see that agnostics that are earning $10,000 to $20,000 in a year are 34. So this goes on. So this is now a tidied data. So you can now use this data for your analysis, or if you want to explore data. If you look at this data now, it's going to be difficult for us to use this data to create a data visualization. So that is why you need to tidy your data. So by tidying it using the pivot longer, that is from converting it from a wide data to a longer data, then you are now going to have this data. So this is what the pivot longer does. It converts a wide table or a wide data into a longer data by compressing the number of columns and increasing the number of rows. So now let's save this data. I'm going to be using it to explain in the next lecture the next function I'm going to be talking about. So let me just call it long data. If you look at the data we created in the previous lecture, and if you look at the initial data, they are both the same thing. It's just that this one is a tidy data, unlike this other one. So this is what we can actually use to create a data visualization and perform analysis, unlike this data that we're having here. So in the previous lecture, we converted a wide data format to a long data format. That is, we compressed the number of columns and increased the number of rows. So in which the columns were now converted to values, as you are seeing it here, less than 10K, 10 to 20K. So the columns were now converted to values under a new column called income, while also the frequencies, a new column was created to contain the values of these what frequencies. So under atheists that are earning less than 10,000, we have 12. So a new column was created called counts, which now contains this frequency. Now in this lecture, I'm going to be showing you how you can now convert this particular data we have here back to this same data. So in this particular situation, we're going to be converting a long format data now to a wide format data. So we want to make the values our columns. So these values that you are seeing here, less than 10K, 10 to 20K, we want to actually make these values as new columns. So we're not going to be having any column called income. And also this count that you are seeing is going to be contained. So that means for under agnostics, then the column 10,000, less than 10,000, then we're going to be having the value 27. So we're in this situation now, we're converting a long data format. We're going to compress the number of rows and increase the number of columns. So we're reversing it. Just take this as a reversal. We want to get this initial data. So let's do that now. So I'm going to pass this was the data we created in the last lecture, long data. I'm going to pass this long data. And the function I'm going to be using is called pivot wider. It's very easy to understand. Pivot wider from the name, expanding the data. That's why it's called pivot wider. Make it wider. Like the previous one, pivot longer, make it longer. Pivot wider, make the data wider. So when the data is wide, then the number of rows is going to become small. Make sure you know the difference. The previous one we use names to, because we are creating a new column. While in pivot wider, we are saying names from. So it's going to create those new columns from where? Then from the values of that particular column. So names from income. Can you see it? Names from income. Then if you check, we have values under that particular income. So for each particular income, we have a value here. Then values from where? Then values from counts. So values is going to be from counts. So the values is going to now be from the count. So when we enter this, you can now see that we are back to the word square one. So this is the initial data that we have. Very easy. So this is just the reversal. So make sure you just take note of these variables. Look at it, names from income and values from counts. So it's reversed it back for us to the initial data we have. So you can see that it has already made the data wider. and it has reduced the length of the data. So it has reduced the number of rows to 18. So this is how you make a data wider. So the next case study I'm going to be using now to also explain this pivot wider for you much more better, I'm going to be using the US rent income data. So let's check for the documentation of the US rent income. So we have the column variable and we have the column estimate. So under variable, we have income, we have rent. So if you can trace it back to the estimate column, you can now see that this income is the median. This is the median income of that particular state, Alabama. This is the median income, and this is the 90% margin of error. This is the median income, so 24,476 is for Alabama, and also the median rent is 747. When you see that of Alaska also, you can see the under income, we have 32,940. which is the median income for Alaska, and we have 1,200 median rent of Alaska. So now the thing we want to do now is that we don't want to have a column called variable. We want to have two columns, income and rent. So under that income and rent, that we're now going to be having this value. So under income, we can know that of Alabama. Under the new column, rent, we can also know the rent of Alabama. So we want to have two columns, which means that by doing that, this number of rows, as you are seeing it, so as you are seeing here, the number of rows that we are having is going to decrease, because in this situation now we are making the table wider, we're making the data wider while compressing the rows, while increasing the number of columns, because we want to create new columns for income and rent, so that we can know that, okay, under income, this is the value of this particular state, under rent, and this is also the value for this particular state. So that is what we are going to do currently now. So now let's go back. So I'm going to pass the US rent income. So we're going to pass this US rent income, we're going to pass it to the function pivot wider. So we want to make the table wider. So I'm going to pass it to the pivot wider. We'll now say names from. So it should take the new column names from where? This is what it's asking you. The argument is telling you. Now, okay, the new column names are going to come from where? They are going to come from variable. So the new columns are going to be income and rent. If we have like four factors here now, like income, rent, expenditure, let's put it like that, let's say 3, we have income, rent, expenditure, then we are going to be expecting 3 columns, income, rent, expenditure. But now we only have 2, income and rent, so we are going to be expecting 2 new columns, income and rent, and we do away with this column variable. So we are going to say names from variable, so it's going to take those names from the column variable. So if we have 3 factors under that variable, let's say income, rent, expenditure, we are going to be having 3 new columns. If we have 2, income and rent, we are going to be expecting only income and rent. So that is what the names from argument does. So the next argument I'm going to be talking about is the values from. So where is it going to be taking the values from after expanding the number of columns? So it has already increased the number of columns. Where is it going to take the value from? So imagine we don't have this column called margin of error. They are now going to say values from estimate. By saying values from estimate, then under each state, we are now going to have, okay, this is the estimate, or let's say the median income for this particular state. Then we also have another column called rent. We'll now say, okay, this is the median rent also for that particular state. But in this situation now, we're having 2 values, estimate and margin of error, which means that we're going to be having 4 columns. We're going to be having estimate income and estimate rent, then margin of error income and margin of error rent. So we're going to be expecting 4 columns in this our data. So it will compress the number of rows instead of having Alabama twice, where for each Alabama we have the income, we also have the rent. Then we also have the estimate, the margin of error for both the income and the rent is now going to create columns for these particular values. So now when we go back, we're now going to say values from. When we say values from, we're now going to use the combine function because we are dealing with 2 columns now, estimate and margin of error. So we'll now say enter. So you can now see that we have our data now, which is already in a wider format. You can see that the number of rows has reduced to 52, from 100 plus to 52. So for each state now, we don't have duplicates, we don't have state duplication, unlike in this data where we are seeing we have duplicate of states, that's in the name variable. In this situation now, we have only what? Each row is just carrying a single state. We have the estimate income column, we have the estimate rent column, we have the margin of error income column, and also have the margin of error rent, as you have seen it now. So these values now have already been placed to their respective columns. So this is how you make a long table into a wider table. So the next data I'm going to be talking about or dealing with is the table theory. This is a default, let's just say a data that comes with the tidyr package. So this is the table, just 6 columns and 3 rows. So if you notice something about this table, you can see that we have 3 countries in this table. 6 columns, but we're having 3 countries: Afghanistan, Brazil, and China. We have the year, so, and we also have the rate. So this is either the rate, this can either be a birth rate or death rate. It was not explained in the documentation of the data, so we'll just take as the rate. It can be birth, it can be death, it can be mortality, so it can be anything. So the rate, and you all know that the rate is calculated as the number of cases divided by the number of population. So when we have number of cases divided by number of population, we're expected to get a rate, whether it is birth rate we're calculating, or death rate, or infant mortality rate, or maternal mortality rate. So this is how a rate is calculated, just the number of cases divided by the total number of population of that particular case study. So now, if you look at it now, we want to separate this particular column that you're looking at rate. We want to split it into 2. So we're going to have a column called cases, and we're going to have a column called population. So now this is where the separate function now comes. So I'm going to pass this table 3, which is our case study table, table 3. You pass it to the separate function. So the separate function allows you to split a column into 2 based on a separator. So now I'm going to say the column I'm splitting is rates. So this is the column I'm interested in splitting rates. And what am I now splitting it into? So I'm splitting it into 2 columns, cases and population. So this is what this argument does. Cases and population, I'm splitting into these 2 columns. Then what is the separator? So I'm going to give my separator, which is what? As you can see, a slash. So you can have a hyphen here, so that means your separator is going to be an hyphen. If you have a space here, your separator is going to be a space. Or if it is by a particular number that you want to use it, or maybe an underscore, then the separation is going to be an underscore. So when I run this now, you can now see that I'm already having 2 new columns. So it has already done away with the rate and split the columns into 2, into cases and population. So this is how you can split a column. We also have another data set that comes with the tidyr package called table 5. As you are looking at it here, country. This is almost similar to what we dealt with before, except that in this situation we're having century and also year. So you can look at this one, already have year. So by combining 2, we're going to have the actual year. So in this place we have century 19 and we have year 99. So in this place we have century 20, we have year 00, we have century year 19, we also have year 99. So now what we just want to do in summary, that we want to combine or unite these 2 columns together, century and year. So we want to join them together. So this is where the unite now comes to. So now for us to join this century and year, we are going to pass the table 5. We're going to pass it to the function unite. Then we're going to see our new column is going to be new. So our new column is going to be new, and the columns that we are uniting, the columns we are uniting to get this new column is century and year. So when you run this, you can now see we have century and year. So but if you look at it, you can now see that we have separators underscore, and we don't need that. So there is an argument called separate, which tells us what the 2 columns are going to be separated with. So by default, the separator is an underscore, but we don't need that. We are not going to use any separator. So by using this quotation marks, we are not using any separator. If I have to use space and I run it, you can see I'm going to have space as a separator. But when I remove the space and I run it, I'm not going to have any separator. So by using this argument sep is equals to no space, or let's say no separation, just ordinary quotation marks, then we're going to be having the 2 columns joined together. So we can also, we have already formed a column called, we have already formed the actual year column. So by joining that century and year columns together. So this is all for the tidyr package. It doesn't have a lot of functions, just these pivots wider, pivots longer, separate, and the unite functions. Not a lot of functions, just try and practice with it, use it to practice. You can practice on various data sets. Like now, if I have to check the documentation of the table 5, so you can see we have a lot of data sets here. So you can try and practice with this data set, or you can try and practice this pivot wider, pivot longer, separate, unite, practice it on this data set as you are looking at it here. So this was one of, I used this data and also used this data, table 3 and table 5. So these are other data which you can also practice on. They come with the tidyr package. So I wish you all the best in the exercises.